Hi, this is Rajnikant Mishra. In today's lecture, we are going to discuss why the volume of the cone is 1/3 of the cylinder. Here in this figure, a cone is inscribed in a cylinder such that the height and the base radius of cone and cylinder are same. According to the geometrical formula, the volume of this cone is 1/3 of the cylinder. Today, we are going to prove it. But before it, let's take a look on previous lecture in which we discussed about sine rule for triangle. Here in triangle ABC, BC is equal to A, AC is equal to B, AB is equal to C, R is the circumradius of the triangle. Then A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R. Cosine formula: A square is equal to B square plus C square minus 2BC cos A. Similarly, B square is equal to C square plus A square minus 2CA cos B, and C square is equal to A square plus B square minus 2AB cos C. The second set of cosine formula is A is equal to B cos C plus C cos B, B is equal to A cos C plus C cos A, C is equal to A cos B plus B cos A. The proof of all these formulas had been discussed in the last lecture. The link of that video is given in the description box. Now, the volume of the cylinder. Here is the cylinder. If the radius of its base is r, the height of the cylinder is h, then we all know the volume of the cylinder is equal to 𝝅r²h. Now we are going to prove it. Here these are identical circular plates of radius r, and we know when these circular plates arrange one above the other, a cylinder is formed. Here the width of each plate is very small, which is dx. Then volume of each plate is base area into height. The base area is 𝝅r², height dx. The volume is 𝝅r² into dx. To calculate the volume of cylinder, we have to add all these volumes. Here we use the concept of integration. Now integrate both sides with limit 0 to h. Here this point is equal to h is equal to 0, and here h is equal to h. Volume V is equal to 𝝅r² integration of dx with limit 0 to h. Here this 0 to h dx is equal to x plus c 0 to h. Here c is a constant. Put x is equal to h plus c minus, put x is equal to 0, 0 plus c. Here c cancel out. The answer is h. So V is equal to 𝝅r² into h minus 0, which is 𝝅r²h. This is the volume of cylinder. The volume of cone. We know a cylinder and a cone both are formed by arranging circular plates one above the other. But in case of cylinder, the radius of all the plates are equal, but in case of cone, the radius decreases continuously from bottom to top and ends at 0 at the apex of this cone. Here this point A is known as the apex of cone. Here the radius of the plate at the point A is equal to 0. Here the width of each plate is equal, which is dx, but the radius are different. Let for this plate, the radius is k, the width is dx, the base radius of this cone is r. Here, this cone is a right circular cone. This angle is 90 degree, this angle is 90 degree. This angle is same in triangle ABM and AON. So, triangle ABM and AON are similar triangles. So, the ratio of respective sides is also same. Here, AB by AO ratio BM by ON. Here AB is equal to x. Here x is the distance of this plate from apex A. AO is equal to h, the height of cone. BM is k, the radius of this plate. And R is the radius of the base of the cone. So k is equal to r into x by h. Now, to find the volume of whole cone, we have to add the volume of all the plates. So, the volume of cone is equal to sum of the volumes of all the plates. Here in this case, the volume of this plate is equal to base area into height. The base area is pi k square, the radius is k, into height, the width of this plate, which is dx, pi k square into dx. Here we don't know the radius of all the plates, but we know the relation between this k, h and r. Let the radius of this plate is y, then after calculation, y is also equal to rx by h, similar to k. So put the value of k is equal to rx by h, volume v is equal to pi, integration sign from limit 0 to h, rx by h whole square into dx. Now v is equal to pi, r square by h square common, limit 0 to h, x square dx. And we know the integration of x square is equal to x cube by 3. Because integration of x to power n is equal to x to power n plus 1 by n plus 1. Here this integration of x square, which is x cube by 3, limit 0 to h, which is h cube by 3 minus 0. So v is equal to pi r square by h square into 1 by 3 h cube minus 0. Now cancel out this h square. The final result is v is equal to 1 by 3 pi r square h. So we can say the volume of this cone is 1/3 the volume of this cylinder. Here is your homework. Here two spheres of same radius are given. In first case, a cylinder of maximum volume is inscribed in a sphere, and in second case, a cone of maximum volume is inscribed in this sphere. If the volume of this cylinder is V1 and the volume of this cone is V2, then find out V1 ratio V2. This is question number 1. Second question, if the radius of this sphere is r, then prove the volume of this sphere is equal to 4 by 3 pi r cube. The solution of both the questions will be discussed in the next video. If you like this video, hit the like button, share it with your friends, and never forget to subscribe and hit the bell icon so that you will never miss any important update.